The following lesson is from Network Plus N10004 Learn Smart Video Training. To find out how you can get unlimited access to our entire Learn Smart Video Training library, call 1-800-418-6789.
The beauty of MAC addresses is that they give us a way to address individual packets so that they can get to the right computer. The problem we have now is, how do you wire all this together in order to make this happen? Now, there's a whole bunch of different ways to do this, and each one of these different types of interconnections are known as topologies. A bus topology starts off where you have a number of computers that are plugged together on one big cable. Now, back in the old days, this cable used to run up in the ceiling, and everybody would connect up into it. In fact, the cable would literally drop down from the ceiling, and wherever that cable dropped down, that was where you screwed in a computer. And we actually still use that word today. We call it a drop. And it comes back from the old days of what's known as a bus topology. Now, what makes a bus topology particularly nice is that when one computer sends out a packet, this packet will be sent across the bus to all the different computers. Now, this is really important. When one computer sends out a packet, that gets to every other computer on the network. And then what takes place is the actual individual network cards themselves, they see that packet as it comes in, they look at the MAC address, they compare the MAC address to their MAC address. If it's their MAC address, that means it's for them. If it's not their MAC address, they just erase it. The next type of topology that was very common was known as a ring topology. A ring topology literally had a ring of wires that went to every different computer on the network. The secret to a ring topology is that there was a direction to it. It would literally go one direction or another. If one computer wanted to talk to another computer, it would send its packet out on the ring, and that packet would move all the way around the network until it got to the computer with the corresponding MAC address. At that point, that computer could also send data, or it could just pass, as it were, and move an empty packet along, and then if somebody needed to send something, they would just send it along, otherwise they would just pass. That was what we called a ring topology. Next is what we would call a star topology. Star topologies were actually very rare. In a star topology, what you would have is all of the different computers hooked to this thing in the middle, which for the moment, I'm going to just call it a concentrator. It's funny, a lot of times when you see these star topologies, they kind of just draw a big circle or something for that intersection. Pure star topologies were extremely rare within the networking world. The last type of, and I got to be careful when I say this, common topology was called a mesh topology. In a mesh topology, every computer is physically connected to every other computer. Now you can imagine if you get a number of computers together, this can become pretty messy, and as a result, there was very few mesh topologies used in the real world. Now, I got to be careful when I say very few mesh topologies used in the real world, because what took place is that within the wired world, we didn't see too much of a mesh topology, but within the wireless world, mesh topologies were and still are extremely common. Now, this is important. There are two ways to make a mesh topology. Classically, if we take a look at the graphic, we can see what we have is known as a fully meshed topology. In this particular situation, everybody is connected to everybody else. And there's no exception. Every connection is to everybody else. This is actually quite rare. Now, if you take a look here, we'll see that we have a mesh topology, but not everybody is connected to everybody else. You can still get to everybody, but you might, instead of being directly connected, you might have to go through one or two other computers. So we have fully meshed topology and we have partially meshed topology. This is critical because you're going to be asked about this in Network Plus. There's a little formula you need to memorize, and it looks like this. When you're working with a mesh topology, you're going to be asked questions like, there are 5 nodes. Now be careful when we say the word node. In a network, a node could be a computer, it could be a server, it could be a printer. It's anybody who's a part of the network. So we have 5 nodes in the network. How many connections do we need to connect all of the computers together to make a fully meshed network? And here's your formula. N is the number of nodes. So you type N times N minus 1, divide the whole thing by 2. The Network Plus loves to ask questions about mesh topologies. So make sure you understand that one very simple formula so that you can get through the 1 or 2 questions you might run into to deal with that. The 5th type of topology is probably the simplest one of all. This is what we call a point-to-point topology. Point-to-point topologies take place when there's really only 2 nodes on the network. One computer directly connecting to another. This sounds kind of strange. Why would people do a point-to-point? A lot of times, point-to-point topologies are how we interconnect 2 other types of networks. So you do see point-to-point, but usually it's specialized networks where you have one network in Toledo and another network in Denver, and you're trying to interconnect them. And that's where you do see point-to-point. The 6th topology to cover is called point-to-multipoint. Point-to-multipoint is rather unique. In this situation, you have a single source that is directing to a number of other sources. There is only one point, and that one has direct connections to a number of different points. You don't see this too often in a physical network because actually if you take a look at point-to-multipoint, watch what happens if we change it around a little bit. It looks like the point is in the center. It almost looks like a star topology, doesn't it? But you got to keep in mind that that is actually a node on the network, whereas with star topology, it's just, there's no computer in the middle. With point-to-multipoint, you have a computer sending something out. These are done in situations where we're trying to do maybe like a video distribution or something like that. So point-to-multipoint is certainly a type of topology, although probably the least likely of one that you'll run into in the networking world. The problem with physical topologies is that they had weaknesses. For example, here's a bus topology. Now, if you take a look at this bus topology, if we were to cut the line, you would not be able to have anybody talk to anybody else. The reason for that is even though the bus only shows one break between 2 computers, is that on the ends of this bus are terminators. So when a signal would go from one computer to all the other computers, when it got to the ends of the wires, it simply terminated. But when you break a wire like that, even when 2 computers are connected to each other, when that signal goes out onto the bus, when it hits that break, it reflects back in and creates what's known as a storm. And as a result of that, that was a big problem. If you broke a bus topology cable anywhere, nobody could talk to each other. So the guys who were making bus topology said, hey, these star topologies are kind of cool because in that case, in a star topology, if we cut any one wire, everybody else can still talk to each other. But we've already designed the bus topology. We don't want to rechange everything, so why don't we do this? Now watch this. What if we take the bus and shrink it, and we shrink it way down, real small? In this case, it kind of looks like a star topology, but it's still a bus topology. This is an example of what we call a star bus topology. It has the propensity of being strong like a star topology. See, the thing here is that if we break any one line, the bus is still intact. In fact, we'll take that whole bus and we'll put it into a little box, and we'll call that little box a hub. And that's the beauty of what we call star bus. Now, do keep in mind that there's another type of hybrid topology, and that type of hybrid topology is called star ring. It works pretty much the same way. Instead of having a physical ring that goes all the way around to every computer, why don't we shrink that ring down? We'll shrink it way down so that it fits within a little box too. In this case, we have the power of the ring topology, but with the strength of a star topology. And those are our 2 types of hybrid topologies, star ring and star bus. In today's world, though, really the major topology is good old star bus. Star bus has got a lot of ground. If I were to walk up to your network today and I had to guess, it's probably using a star bus network. But keep in mind that even though you and I may not be seeing a lot of these topologies at a basic level, Every single topology we've discussed in this section